This is Flappy Bird Day 4, and before we begin, let's review Day 3. So in Day 3, we got pipes and collisions working, which looks like this. When you run the game, we have pipes, both a bottom pipe and a top pipe, and they appear every 100 act steps. Also, the height of the pipes is a random number. So right there, they're about the same height, but in a little bit here, you'll see either a taller or shorter pipe set. So currently, they're all about the same, but it's random. There's one, so a little bit higher. There's one, same height. That one's a little bit higher, and so on. So the height of the pipes is random. When we crash into pipes, then it's game over, like right there. But there's a problem. Do you see the space between Flappy Bird and the pipe? We're going to fix that today. Second, there's a paint order. So first, Flappy Bird is the bottommost object, and then pipes on top of that, and then game over. In Greenfoot, you can set the order in which objects are drawn, and so we're going to set the order so that Flappy Bird is on top of pipes. And then finally, we're going to make it so that when Flappy Bird goes through a pipe, he gets 1 point added to his score. So that's our goal for Day 4. Before we begin with scores, we need to do some code cleanup from Day 3. We have duplicate code inside of our Flappy Bird code, so let's go clean that up. Go ahead and open up Flappy Bird and look at this. If we are touching a pipe, then it's game over time, 3 lines of code. But the same thing happens. If we are touching the bottom of the screen, it's also game over. These are the same 3 lines of code to do game over. You should really not repeat 3 lines of code twice. So let's cut this out and make a helper function. So I'm going to say private void, let's call this display score. Display game over, display game over. And then I'm going to go ahead and paste in those 3 lines of code. So now, instead of typing out these 3 lines of code, you can just say game over. Here's a quick explanation of the parts. Private means that this function can only be called from inside this class. Void means that this function does not return a value, like it doesn't return an integer or a string, it just does a job. And finally, this is the name of the method, display game over. So if we are touching a pipe, then it is game over time. And secondly, if we fall off the edge of the world, then it's also game over time. This is way easier to read code. If touching a pipe, then game over. If falling off the edge of the world, same thing, game over. It's much easier to read this than it is 3 lines of code. So please use helper functions to reduce the amount of code you retype and to make your code more readable. The more helper functions in general, the better. So there was goal number 1. Next up, code order. Currently, we are checking for pipe collisions before set location. Check it out. This is inside of Flappy Bird. First, we set the location, and then we check for collisions. The problem with this is that it leaves some space between Flappy Bird and the pipe, like this. Here comes the pipe, and if I go to touch it, there's space between Flappy Bird and the pipe. And here's the reason. Let's go back to the code for Flappy Bird. Okay, first, we're updating Flappy Bird's location, but the problem is that you don't actually see the results on the screen until after the act method finishes its job. But in this case, if we update Flappy Bird's location and touch a pipe, we're going to basically end the game before the act method has a chance to really finish. So that's the problem, that you don't actually see the results. Even though Flappy Bird is touching a pipe, you don't see it because the game ended first. So we're going to change the order of this code and move this below pipe intersections. That way, if we're touching a pipe, you'll be able to see this 1 frame later, basically. So we're effectively delaying what you see for 1 frame of animation, which has its pros and cons. So here's the end result. Changing the order of the code will fix this problem, but now there's a new problem. See how Flappy Bird is into the pipe? there's really not a way around this. I mean, there is, but it's way more advanced. So let me do a bottom pipe. Okay. Currently, Flappy Bird is into the pipe like this. Well, the thing is, before he was here, he used to be up here. But those are your only two choices because in the first frame, he was here, and in the very next frame of animation, he was here. There was no in the middle. So as a programmer, for now, you only have two choices. Either you end the game before he touches the pipe, or after he's touching the pipe. You can't really do it when he's exactly at the pipe. I mean, you can, but that's much more advanced and it's beyond the scope of what we're going to do. So I recommend this second choice over the first choice. And what we've changed our code to is that second choice. So code order does make a difference. If you find collisions to be stopping early, you might check to see the order of your code where you do set location versus where you check for collisions. So keep that in mind in the future. Okay, next up, paint order. Currently, we have Flappy Bird being drawn, and then pipes are drawn on top of that, and then game over objects. Let's go ahead and change the order in which these are drawn. So in the World API, which I have opened right here, there is a function in the World API that will do this. It's at the bottom. It's called setPaintOrder, and to use it, you pass in a list of classes. So I'm going to just go ahead and use it and show you as I go along. So we're going to put this in Flappy World. So open up your Flappy World, and right after we create the world, let's go ahead and set the paint order. Set paint order, paste in our function, and now let's use it. I want pipes to be the bottom object, so I'll say pipe.class. Then I want Flappy Bird to be the next kind of object drawn. And on the top, I want game over objects. And you can change this to your liking. But the way it works is whatever you put on the bottom here, on the first, as the first parameter, this will be the bottommost object. All the way through whatever's at the end of the list is the topmost object. So go ahead and change this order to whatever you want. And in the future, as you're adding to your program, remember to update this and change it so that it draws the objects in whatever order you choose. All right, our final goal for today is to enable scores so that every time Flappy Bird goes through a pipe, he gets 1 point added to his score. So first, let's go ahead and add a score variable to our world. Open up your Flappy World code, and at the top with our current global variables, let's go ahead and add a variable for score. And let's initialize it to 0 to start with. So add a score variable, and next up, we want to increase the score variable every time Flappy Bird crosses through a pipe. But to do this, it's going to take more work. So let's break that process down. All right, one change. Let's look at the way we're currently counting steps in the world. Open up your Flappy World, and we already have a counter. Remember, here's what this counter does. Every single time we act the world, we increase the counter. And for now, I've printed it out so you can just kind of see what it's doing. It's currently, we're increasing the counter. Once the counter reaches 100, we create some pipes and reset the counter. Now, create pipes is a custom function, a helper function that I wrote. You probably have code here instead, but remember, this is not a Greenfoot function. It's one that I made. So I took my code out of here and put it into a helper function. So this is my own function, and it's what you did in day 3. Anyway, let's look at the code running. Let me find my output window so we can see it. Here it is. Okay, as I run the program, you can see we've got numbers flying by. Let me slow it down real quick. And these numbers represent the counter. The counter is simply counting every frame of animation. And every time the counter gets to 100, a new pipe pops up. So when this got to 100 over here, we spawned a brand new pipe over here, which slid into view. So that's what we're doing currently. What we want to change is we don't want the counter to reset back to 0 every time. 0 is actually right here, so it's displayed. Instead, go to your Flappy World. We still want the ability to create pipes every 100, but we do not want to reset the counter to 0. So delete the counter equals 0 resetting, and instead we're going to pop up pipes every 100 by doing this. If counter modulus 100 is 0, what this means is if when we divide counter by 100, the remainder is 0, then create a pipe. This will do effectively the same thing. So every time the counter is divisible by 100, create a pipe. The result is the exact same thing as before, except for the counter is never reset, and we need this capability to keep track of Flappy's score. So check this out. See, now the counter keeps going, but when it reaches 200, boom, new pipe. So as soon as this hit 200 up here, then a new pipe was created, that's this one. When it hits 300, another pipe will be created, and so on. But now we can see the counter just increasing over time. That's what we need. So next, let's find out what is the counter value when we should add our first point to Flappy. So rerunning this. Here comes the pipes, and let me slow it down and get our output window back. So currently I'm at a counter of 189. So we shouldn't get a point until Flappy reaches past this first point. And we're still waiting. So when should we get our first point? Well, not quite yet, because Flappy's not past the first pipe. But I'd say right about here. So I'm going to stop there. So Flappy's just past the pipe. I want to say that 240 is the counter value at which we should get our first point in this game. So let's remember this 240 number and add that to our code. So back to our code. Go ahead and open up Flappy World, and let's save 240 to a variable. Let's call this, let's see, int first pipe. So the first pipe really appeared at a counter of 240. And what we want is, when the counter reaches this value, we want to give Flappy his first point. So down here, actually we don't have a score variable. All right, let's add that. No, we do, right here. So once the counter reaches this value, we want to add a point to Flappy. So let's go ahead and do that down here. If the counter reaches, instead of hard coding 240, we're going to use first pipe. So if the counter reaches exactly 240, then we would like to increase the score of Flappy. Perfect. So this will give us our first point. Cool. And we'll go ahead and print out the score. And let's not print out the counter. So this should work and give us our first point. Let's make sure it does. Okay, let me clear out the current. Let's speed this up. So the counter is increasing. We can't see it, but it is. And once we pass up our first pipe, when the counter is 240, boom, 1, there's our first point. Now we will never get a second point because we only said when the counter is exactly 240, then you get your first point. So we need to fix that. All right, there are many ways we can go about this. The way that I've chosen for this tutorial is to have 2 counters. We're going to have one counter that counts when to pop pipes up, and a second counter to count when to increase Flappy's score. So instead of calling this counter, we're going to call it pipe counter. And I'm going to replace all the counters with pipe counter. So here we're going to increase the pipe counter. When the pipe counter reaches a multiple of 100, create a pipe. And when the pipe counter reaches its first pipe value, we're going to go ahead and increase our score. That's all well and good. And now we're going to add the code for a second counter for Flappy. So we have pipe counter. Let's add a second counter. Integer, it's called as Flappy counter, equals 0 to start with. And the code's going to be very similar to this code here. So we're going to try to count every multiple of 100 of Flappy's counter, then increase the score. Alright, so once we reach the first pipe, we do want to increase the score, but what we really want to do also is keep track of whether or not Flappy's counter is a multiple of 100. So this is what we want to do here. The same thing as before, except for do this for Flappy's counter. So once it's time to start tracking, we're going to see if Flappy's counter is a multiple of 100. And if it is, we want to increase the score. And then after that point, we're going to increase Flappy's counter. And let me print this out just so we can see it. So here's what we're trying to do. This section of code creates a pipe every 100 steps. Once the pipe counter reaches our first pipe value, then we start tracking Flappy's counter, which is a separate counter. And so each time the Flappy's counter is a multiple of 100, we increase the score, print it out so we can see it, and then we increase Flappy's counter. Go ahead and make that change there. That was increase his counter. But none of this Flappy counter starts until we've hit the first pipe. That's the key. So let's go and see if it's working. Here's my output window. I'll clear this out, compile, run, and I'm going to keep the program fairly slow so I can actually make it through my pipes. So here he goes. Okay, 1 point, cool. And then I did make it, but over here would have appeared point number 2. Let me retry, unfortunately. Alright, I can do this. Here we go. We've got 1 point, cool. And there's a second point, which did not pop up. So let's go review what happened. Alright, double checking. There's our first point, cool. Here is, okay, it's not giving a second point, so we have a bug, no problem. Let's go check it out. Alright, Flappy counter and pipe counter are starting at 0, no problem there. Once the pipe counter always increases every single time. Once the pipe counter, aha, here's our problem. Currently we're saying if the pipe counter is exactly equal to the first pipe value, then do these things. What we really want is this. Once the pipe counter reaches or is beyond the first pipe, then start keeping track. Before I said double equals, well, it should be once we've met or exceeded the first pipe, then we start tracking the score counter. So that was the logical problem. Alright, this should work. I have confidence. Here we go. Resetting, rerunning, and here it goes. So here comes the first pipe, and here comes our first point. Right now, check. Second point, right now, check. Cool, it's working. There's 3. Here comes 4. Awesome. Here comes 5. And so our score system is working perfectly. So Flappy Bird is timed to pipes because we're keeping a track of a second counter just for him. Cool. So that's our day 4. Now there is homework, and here's what it is. Go ahead and try this on your own. Instead of displaying the score in the console, try to draw it as a graphic object on the screen. And to do this, one way to do it is create a score actor, and then basically you draw on top of its image. So spend some time, 15 minutes, 20 minutes, trying this yourself, and tomorrow we'll do it together, but it matters that you try it yourself, because in doing so, you'll basically investigate things that you wouldn't have investigated before, and you'll be thinking things, and you'll be basically finding barriers. You'll basically say, well, how do I do this or that? But making your brain ask those questions will make tomorrow's code much more useful and meaningful. So please try this for about 15 to 20 minutes on your own and see how far you get. All right, take care. See you tomorrow.